welcome to the Chemistry, Biology and Math Revision Hub. Today we are doing the Pearson Edexcel International GCSE for the Pure Mathematics Paper 1R for January 2022. This is the Part 1 video. I'll put the link to the Part 2 video below in the description box. Let's begin with question 1. Question 1 says, on the grade below, draw the graph of the line with the equation 4x plus 5y is equal to 20 and 3y minus 4x is equal to negative 12. So here, I use 2 points for each equation. When x is equal to 0, I found the corresponding y coordinate and drew the line. And when y is equal to 0, I found the corresponding x coordinate and drew the line. So that line was this here. You can see the points I used are that and that. When x is equal to 0, y was 4. And when y was equal to 0, x was 5. And then for this here, I did the same thing when x is equal to 0 and when y is equal to 0, and I found their corresponding coordinates. You can see when x was equal to 0, I got y is equal to negative 4. And when y was equal to 0, I got x is equal to 3. So I drew a straight line through them. So that's it for getting 2 marks here. And then part B says, show by shading on the grid the region R defined by the inequalities, which are these. I already drew this line and that line, so all I needed was that line and that line. The line x is equal to 1 is this one here. You can see that. And the line y is equal to 3 is this one here. Now the next point is for me to shade the wanted region based on the inequalities given. So to find the region that is wanted, which is 4x plus 5y is less or equal to 20, you have to go to the line 4x plus 5y is equal to 20 and find a corresponding wanted region. For that, I refer to the point 0, 0, which is the origin, this point here, to see if this region is in the wanted region or not. Referring to the point 0, 0, for x plus 5y is less or equal to 20 should be 0 plus 0 less or equal to 20, and this is true. 0 is less than 20, therefore the region 0, 0 for that specific line is in the wanted region. So for this line, this region here is in the wanted region, so ignore that, this is out, and then this region is what we're interested in. So 3y minus 4x is greater or equal to negative 12. Again, I refer to the point 0, 0 and substituted here. I got 0 minus 0, which is 0. We see 0 is greater than negative 12. And that means that region 0, 0 is also in the wanted region for this other line. Get this out, and then this is going to be the region of interest. Now, when we go here to y is less or equal to 3, of course, this is the wanted region this side. And then x is greater or equal to 1. This is the wanted region, so this region is going to be out. So when I shaded, this is my region R as required. So moving on. Question 2. The nth term of an arithmetic series is un. Given that u5 is equal to 46 and that u20 is equal to 181, find the common difference of this series and be the first term of this series. So remember, any term in an arithmetic series is given by un is equal to a plus n minus 1d. So the fifth term should be a plus 5 minus 1d, which is a plus 4d. And since a plus 4d is equal to 46, that is my equation 1. So for the 20th term, u20 should equal to a plus 19d, because this is going to be n minus 1d, meaning 20 minus 1d, which is 19d, and that is equal to 181. So this is my second equation. So I have 2 simultaneous equations that I can solve using the elimination method because they both have an a. So I rewrote these 2 equations here and I subtracted to ensure that this becomes 0. So I got negative 15d is equal to negative 135, and therefore my d is equal to 9. Remember, the question wanted us to find the common difference, which is 9, and the first term. The first term is a, so I substituted into this equation here. A plus 4 times 9 is equal to 46. And when I simplified, my a was equal to 10. So the first term is 10, and the common difference is 9. So when we see the next question, they say B, evaluate the sum from the term n is equal to 21 to n is equal to 50 of this arithmetic series. To find this sum here, it should be the sum of the first 50 terms minus the sum of the first 20 terms. So we know for any arithmetic series, the sum of the terms is equal to n over 2 into 2a plus n minus 1 times d. So for the first 20 terms, it's going to be 20 over 2 into 2 times 10, because a is 10, plus, this is the first 20 terms, so n minus 1 is 20 minus 1, which is 19, times dot d, which is 9. So to simplify, I got 10 into 20 plus 171. And finally, S20 is equal to 1910. This is the sum of the first 20 terms of this series. Then when we go to the first 50 terms, again referring to this equation here, S50 is equal to 50 over 2 into 2 times 10 plus 49 times 9. And again, this is n minus 1. 50 minus 1 is 49 times d, the common difference. So this is 25 into 20 plus 441, and that is 25 times 461, which is 11525, and that is the sum of the first 50 terms. So the difference between the two is going to be 11525 minus 1910, which is 9615, and that is the answer to question 2. Moving on. Question 3. The point A has coordinates 17 and the point B has coordinates 93. The line L is the perpendicular bisector of AB. When they say this is a perpendicular bisector, it means it divides that line into half. They want us to find an equation for line L. I began with line AB, and this is my sketch, the coordinates for A as well as the coordinates for B, and I assumed the coordinates for the midpoint are X and Y. So to find the gradient of AB, it should be the Y coordinate here minus the Y coordinate there, divided by the X coordinate here minus the X coordinate there, and this gave me that, which is negative 1 over 2. So we can know that the gradient of the perpendicular bisector is going to be 2, since these two lines are perpendicular. Now, we need to find the coordinates for the midpoint in order to find the equation of the line, which is the perpendicular bisector. To do that, the X coordinate should be the X coordinate here times 1 plus the X coordinate here times 1 divided by 1 plus 1, which gave me 10 over 2, and therefore that was 5. And the Y coordinate here should be the Y coordinate there times 1 plus the Y coordinate here times 1 divided by 1 plus 1, which gave me 10 over 2. And again, I got 5. So the coordinate for the midpoint is 5, 5. Now to find the equation of the perpendicular bisector, it should be Y minus this Y coordinate divided by X minus that X coordinate is equal to 2. And therefore 1 minus 5 is 2 into that. To simplify, by making Y the subject, I got Y is equal to 2X minus 5. This is the equation of line L, which is the perpendicular bisector to line AB. The next question asks, the line L crosses the x-axis at a point C. That means at that point, Y is equal to 0. They want you to find the area of the triangle ABC. So here, this is my sketch. Again, this is line AB, and that is the perpendicular bisector. So I first found the coordinates for point C, which are that. We know this line has the equation Y is equal to 2X minus 5. And at C, we know it crosses the x-axis, so Y is equal to 0. So this becomes 2X minus 5 is equal to 0, and X is going to be 2.5. So the coordinates here are 2.5, 0. To find the area of this triangle, this is going to be the height, and this is going to be the base. So area is a half times base times height, which is a half times AB times CM. So my next part is to find the length AB as well as the length CM. Length AB is equal to the square root of the Y coordinate here minus the Y coordinate there, everything squared, plus the X coordinate here minus the X coordinate there, everything squared. And when I simplified, I got root of 80, which is written as 4 root 5. Now for CM, I did the same thing. The Y coordinate here, which is 5, minus the Y coordinate here squared, plus the X coordinate here minus the X coordinate here squared. Also, I got root 125 over 4, which is 5 over 2 root 5. So I have this, and that I can substitute into this equation. So my area is equal to a half times 4 root 5 times 5 over 2 root 5, and it is equal to 25 square units. So that's the answer to part B of question 3. So this brings us to the end of question 3. Let's continue to question 4. Question 4. In question 4, we have a sector here, and we can see there is a triangle inside that sector. So they say figure 1 shows a sector or AB of a circle with center O and radius R. The angle AOB is pi over 3 radians, and the point D divides OA in the ratio 3:1. This means if this is radius, that is going to be 3 over 4 radius, and that is going to be 1 over 4 of the radius. They say the area of region R shown shaded in figure 1 is 79.5 centimeters squared. Calculate the value to two significant figures of R. So we need to know that shaded area should be area of a sector minus the area of a triangle. So here I said shaded area, which is 79.5, should equal to the area of the sector, which is a half r squared theta, minus the area of the triangle, which is a half AB sine C. So substituting, I get 1 over 2 radius squared times the angle, which is pi over 3, minus a half times AB. A is going to be this one here, and B is going to be that, whichever you choose. So which is 1 over 2 times 3 over 4r times radius times the sine of pi over 3. To simplify this, I get that. And to simplify this, I get that. Remember, when you're finding the sine of pi over 3, your calculator should be in radians so that you can find the appropriate answer. So making r squared the subject, I got r squared is 79.5 divided by 0.1988, which gave me that. And therefore my r was 19.995, which is approximately 20 centimeters, because my answer was supposed to be in two significant figures. So 20 centimeters. In part B, they say, calculate the perimeter in centimeters to two significant figures of the region R. So again, this is my sketch. If I want to find the shaded perimeter, I need to find that, I need to find this, and I need to find that. To find this, I use the cosine rule. However, I needed to find this one here. Remember from my previous calculation, length OD is 3 over 4 the radius, which is 3 over 4 times 20, and that gives us 15. So this one is going to be 20 minus 15, which is 5. So if the radius is 20, this is going to be 20. So using the cosine rule, dB squared is equal to 15 squared plus 20 squared minus 2 times 15 times 20, the cos of this angle. So when I substituted, I got 625 minus 300, which is 325. And to find the square root of that, I got 5 root 13. So that is going to be length dB. I already know length dA, so I need to find that length, which is the arc length. Arc length AB is equal to r theta, which is the radius 20 times the angle, which is pi over 3. And that gave me 20 over 3 pi. So the perimeter is going to be the sum of the 3. So I got perimeter is dB plus dA plus AB, which is 5 root 13 plus 5 plus 20 over 3 pi. I got 43.9717, which is 44 centimeters to two significant figures. So this brings us to the end of question 4. Let's continue to question 5. Question 5, f of x is equal to 1 plus ax power n, where n is greater than 2. Part A says, write down the expansion of f of x in ascending powers of x up to and including the term in x cubed, and give each coefficient in terms of n and a. So this is the expansion they want us to create, and I rewrote it as using binomial expansion. This is going to be 1 plus nx plus n into n minus 1 x squared over 2 factorial plus n into n minus 1 n minus 2 ax cubed divided by 3 factorial. And to simplify, I got 1 plus nax plus n into n minus 1 a squared x squared divided by 2 plus n into n minus 1 n minus 2 a cubed x cubed divided by 6. That is the expansion and the answer to question A. For part B, they say, in the expansion of f of x, the coefficient of x is 8 and the coefficient of x squared is 30. They want us to find the value of n and the value of a. If we can see, the coefficient of x is na, so this is equal to 8. And the coefficient of x squared is this one here, which is that, and it's equal to 30. So we have two simultaneous equations. Using this equation to make a the subject, I get a is equal to 8 over n. Now I'm going to substitute for a into this equation too. I got n into n minus 1 over 2 times 8 over n squared is equal to 30. And therefore n into n minus 1 times 64 over 2n squared is 30. I then got n into n minus 1 times 32 is equal to 30n squared. So here I tried to simplify and I created a quadratic equation we see here. And this is the same as n into 2n minus 32 is equal to 0, where n is equal to 0, or 2n minus 32 is 0, and n is equal to 16. So I get the value of n. The next part is for me to find the value of a. But from this equation star on the previous page, we know a is equal to 8 over n. So 8 divided by 16 gives me a half. That is the answer to part B, which was that. Part C says, calculate the coefficient of x cubed in f of x. So you see, this is the coefficient, this one here. So I have to substitute for n as well as for a to find the suitable answer. So down here, that's what I did. If we have that as the coefficient, it's going to be, our n is 16, so 16 times 15 times 14 times a, which is 1 over 2 cubed, divided by 6. When you calculate, you get 70 as the answer. So this brings us to the end of question 5. Let's continue to question 6. Question 6. The points P, Q, R, and S are the vertices of a quadrilateral PQRS such that PQ is 2i plus 3j. This is vector PQ. Vector PR is negative I plus 18j. And vector PS is negative 3i plus 15j. They say show that PQRS is a parallelogram. So I sketched here. Actually, it's not a requirement for you to sketch, but I sketched so that you can visualize what we're talking about. If PQ, R, and S is a parallelogram, it means PQ should equal to SR and QR should equal to PS. As we can see here, their vectors should be equal. So I began by finding vector QR to see if it will give me that. And again, in this sketch, I also included vector PR, which was given. Using this sketch, we can see that vector QR is equal to vector QP plus vector PR. But vector QP is going to be negative of this whole vector, which is what I put here, plus that, which is negative I plus 18j. And when I collected the like terms, I got negative 3i plus 15j, and that is vector QR. And actually, you can see it's equal to vector PS. The next part was for me to find vector SR. Vector SR should be SP plus PR. And again, this is going to be the negative of that. So we get negative of vector PS plus I plus 18j. And that gave me 3i minus 15j minus I plus 18j, which gave me 2i plus 3j. We can see this is the same as vector PQ, and therefore this is a parallelogram because the sides or the vectors are equal, or parallel vectors are equal. So it's a parallelogram. In part B, they say find a unit vector prior to QS as a simplified expression in terms of I and j. A unit vector prior to vector QS should equal to vector QS divided by the magnitude of vector QS. Now I began by finding vector QS, which is that vector QS can be QP plus PS. So I put that here, which is negative into 2i plus 3j plus that vector, which is that. And then I got negative 2i minus 3j minus 3i plus 15j, which is simplified into negative 5i plus 12j. This is vector QS. And then to find the magnitude of vector QS, it's going to be the square root of negative 5 squared plus 12 squared, which is the square root of 25 plus 144, and therefore it gave me 13. So to rewrite the answer as required, the unit vector prior to vector QS is going to be the vector QS divided by the magnitude. So for part C, they say the point T lies on QS such that QT to TS is equal to 5 to 8. Find PT as a simplified expression in terms of I and J. I sketched this here because they gave us this vector T lies along this place, so that QT to TS, the ratio is 5 to 8. If it's 5 to 8, then it means QT is 5 over 13, vector QS, and this is going to be 8 over 13, vector QS. So to find PT, vector PT is going to be vector PQ plus vector QT. We know this already, so I put 2i plus 3j plus 5 over 13, which is that part here of vector QS. But we already know vector QS, so I substituted for vector QS, and therefore my vector PT is equal to 2i plus 3j plus 5 over 13 into negative 5i plus 12j, and this gave me 2i plus 3j minus 25i over 13 plus 60j over 13, which is equal to 2 minus 25 over 13i plus 3 plus 60 over 13j. And to simplify, my vector PT was 1 over 13i plus 99 over 13j. So this brings us to the end of question 6, as well as to the end of this first part of the paper. Thank you for being with us. Do not forget to subscribe. See you in the next video. Bye-bye.